Perfect. Thank you everyone for making it all the way to the end of today and to my presentation in which I will talk about DNA synthesis screening. So today we have the technology to synthesize every DNA sequence that we want, basically. And this has brought enormous benefits to biomedical research, but it also comes with risk, as synthetic DNA could be misused by nefarious actors to create bioweapons or cause pandemics. And DNA synthesis screening is one quite straightforward way to mitigate these risks. And in the past 2 months, I have been working on a project aiming to pinpoint the open questions and challenges that remain for regulatory oversight on DNA synthesis screening. And I had the pleasure of working together with two fantastic mentors, Jonas Sandbrink and Sophie Rose. And my work supported a civil servant at the UK Department for Science, Technology and Innovation. Yeah, I'll start by giving you a bit of a background on DNA synthesis. So there are several dozen synthesis providers in the world who provide services to synthesize DNA. And modern biosciences heavily relies on these services, as a lot of different technologies and research areas like vaccine development, diagnostics, gene therapy, etc., all rely on these services. And there are two main ways how you can order DNA. One is to order it online. There are these like handy online forms. You fill in your name, give a bunch of details about your company, what you use it for, and the sequence that you want to have synthesized. And they basically produce it, ship it to you. Within a few days, you have a vial of your DNA. The second way, which is becoming more and more widespread, is using benchtop DNA synthesis devices, like the one you can see here. So these are small devices that are suitable to be used on a research bench, and they kind of accelerate the build, design, test cycle. But they also make DNA synthesis more accessible, which also increases the risks that we face. And yeah, again, synthetic DNA could be misused by malicious actors to create bioweapons or cause pandemics. And this might be particularly important because we see rapid advances in synthetic biology. And for the first time in history, it could be possible to actually create pandemics that are more dangerous than the ones we've seen in the past. And as such, I think synthetic DNA misuse is a risk factor in global catastrophic biological risks. So what actually is DNA synthesis screening? As I mentioned, it's a method to mitigate the risks of misuse. And it mainly consists of two parts. The first one is sequence screening. So basically, you take the sequence that your customer ordered, you compare it to a huge database of dangerous sequences of concern. If there's a match, you flag the sequence and you check the customer to see if they're actually allowed to order this. And yeah, this leads me to the second one, which is the customer screening. So basically, making sure your customer is a legitimate researcher who is allowed to work with DNA sequences from influenza viruses, for example. And such screening measures already applied by several companies around the world. However, not all companies do them, which leaves some security loopholes that could be exploited by nefarious actors. So can everyone create a pandemic in their bedroom now? No, definitely not. So beyond the acquisition of synthetic DNA, there still remain some hurdles for creating viruses, such as the printed DNA sequences are much shorter than the ones of viral genomes, so you'd have to order a few of them and stitch them together, which takes time and expertise. There are also some other technical hurdles for creating a virus, for example, taking the genome and actually turning it into a virus. It's not easy. You will need a lot of troubleshooting and experience. You need access to lab equipment, and it just requires a lot of expertise and skills. But with recent advances in AI, this could dramatically change. On one hand, large language models could help with troubleshooting experiments, providing easy access to data on pandemic-capable pathogens, and in general lower the barriers for misuse. And on the other hand, we see AI-based biological design tools that could raise the ceiling of capabilities and basically help us create viruses that can do things that we haven't seen in the past. So I think this is reason for concern. So the goal that we want to achieve, ideally, is universal DNA synthesis screening. Every single company that provides synthesis services should screen their orders. And right now, there is a massive window of opportunity for advancing synthetic DNA screening regulation, as the UK recently updated their biosecurity strategy, mentioning this as a measure that they want to implement. And the US is also updating their synthesis screening guidelines, so a lot of work is being put into this at the moment. But the details of any regulation still have to be figured out. So there's a need to identify what questions should policymakers even ask when designing a policy, and what unsolved questions do they definitely need to find answers to when implementing this. So in my project, I worked on DNA synthesis screening regulation, specifically in the UK. And my work tried to support a specific civil servant at the UK Department for Science, Technology and Innovation, who is tasked with looking into this. The main goals of my project were to compile a list of open questions and challenges, to help steer the policy effort in a more ambitious direction rather than having like too soft policy, and to generally learn about biosecurity policymaking. The approach that I took was that I first researched the DNA synthesis landscape in general, compiling a list of stakeholders and trying to get some numbers on who produces the synthetic DNA of the UK, basically trying to find out who would a regulation affect. I also read a lot of existing policy proposals, summarized them for the civil servant I worked together with, and identified some of the gaps. And I also interviewed some experts and stakeholders. So briefly on the UK DNA synthesis landscape, there are roughly 10 UK-based synthesis companies. It's hard to tell. There are not like extensive lists, and many of these companies provide several services, so it's hard to find all of them. But roughly 10 synthesis companies in the UK. The big players on the global synthesis market, however, are mostly based in the US, and the UK-based companies, in comparison, are rather small and serve like small market niches. So this led me to the conclusion that there's general uncertainty about what fraction of UK synthetic DNA is actually produced in the UK. I think, although there is very little public data about it, that most of the synthetic DNA in the UK is actually imported. But nevertheless, the UK is one of the top life science innovators in the world, and as such, they are in a good position to take a lead together with the US on this issue. There are two main regulatory options that are constantly named. One is mandatory screening guidelines. So basically, a government could say, every synthesis provider in my country has to follow these guidelines if they want to sell synthetic DNA. And the second option is voluntary guidelines, saying, here is a set of guidelines, you can follow them, you don't have to, but if you follow them, we have a few goodies for you. For example, we could mandate all government-funded research to only source DNA from such providers, so they have an advantage. But these are like the high-level decisions that policymakers would need to address. But there are several like sub-questions, and as you go into the details of how a regulation would need to be operationalized, there are a lot of questions. And yeah, I compiled a long list of questions. I'll just quickly give you 3 of the questions that I thought were interesting. One is controlling the import of synthetic DNA. So basically, how do we make sure that all the DNA in the country is safe and screened, and not only the one that is produced in our country? Yeah, there are a lot of questions around this. Another one is maintaining the sequences of concern database, which is not straightforward. You have to have a lot of expertise in pathogenicity to actually determine which pathogen sequences and which parts of a pathogen sequence should get into the database to avoid false positives. And then who should host it, who is in charge of updating it, how strict should we be with information security measures, etc. And the last point I want to present is the adaptation of screening practices to future threats. So right now the baseline goal should actually be to get everyone to screen, but we should also make sure that the screening guidelines stay effective in the long term, especially now that we see AI-based design tools on the rise that could help us circumvent measures in the future. Yeah, these were 3 examples of questions that I found. I compiled all the outcomes of my research into 2 policy briefs to the civil servant, one on the landscape and regulatory options, and one as a huge list of challenges in operationalizing the synthesis screening regulation that we found, and hope to turn into a paper soon. So my next steps are to continue interviewing stakeholders. There are a lot of companies out there, they're very busy, and I hope to get hold of more of them. Then also deep dive into some of the identified challenges and try to make progress on them. And finally, turn a list of challenges into a paper. Yeah, and that was it. I'm open to your questions now, and thank you everyone for attending and organizing.